Hello everyone, welcome to The Biggest Ideas in the Universe. I'm your host, Sean Carroll. Today's big idea, quantum mechanics. You knew this was going to happen. This is one of the biggest ideas we have. Like a previous idea, time, and to be honest, quantum mechanics is such a big topic that it's going to be more than one idea. But in this particular video, we teach our undergraduate students in physics classes about how to use quantum mechanics, okay? Then there's deeper mysteries about how quantum mechanics really is, what the ultimate description of reality, according to the quantum viewpoint, should be thought of as, and that will come in a subsequent video. But right now, how to use quantum mechanics. So by the time this hour is over, you'll be at the level of a, sophomore at Caltech or something like that, minus some mathematical details. And I don't want to be too historical about it. We've never been very historical in these lectures, but we can be inspired by history. So I'm going to move into quantum mechanics in a sort of pseudo-historical way. And the reason for doing this is because quantum mechanics is so radical, is so different. It's such a big break from the previous way of doing physics that it really is important to motivate it, not just to state what is going on. Unlike special relativity, where I just sort of told you the answer, in quantum mechanics, I would really like to see why that is what the answer apparently is. And then, maybe you'll be empowered to think about other ways that it could be. However, I'm not going to stick to the actual history of quantum mechanics too much. It's too rich, too interesting, too complicated. There were all these brilliant minds arguing with each other. We're going to do a simplified version of quantum mechanics. And, the reason for all of this throat clearing is quantum mechanics is special in the whole world of physics, in the whole set of physical theories ever invented. Everything we've been talking about up till now has been in the context of this classical paradigm for doing physics, handed down to us by Isaac Newton and others. Quantum mechanics is a replacement for classical mechanics. No one before the 20th century thought that classical mechanics would need to be replaced. It was just working so well. Everyone thought it was just going to be a matter of figuring out what is the specific version of classical mechanics that we would need. So quantum mechanics comes along. It tells us something completely different about the world, and that thing is so completely different, so alien to the ways that we think, that even today, we don't claim to really know the final answer for what quantum mechanics is all about. So that's why we need to break up the discussion into sort of the accepted parts, the used way that we approach quantum mechanics, and then the deeper parts that are still controversial. We don't actually know many answers to questions that are very easy to ask about quantum mechanics. So that's why it's so important. Quantum mechanics is simultaneously absolutely central to all of modern physics, and yet something that we don't claim to understand. So to get there, the way I like to do it is to actually imagine a fake history, physics that didn't actually happen.